good day, friends. Hello, good day, folks. Hello, good day, all math lovers. You are welcome to my channel, Math in a Flash channel. Today, we'll be looking at numerical processes. What are numerical processes? So, we're talking about fractions, decimals, percentages, and we'll continue a number basis class. So, what's the objective of this topic? The objective is to help students with the ability to subtract, multiply, and divide fractions. That's number one. Number two, to solve real life problems using fractions, decimals, and percentages. Number three, we'll be looking at ways by which we can add, subtract, multiply, and divide numbers in various bases. And just like you know, the objective of this channel is to give you leeways into solving questions easily. So I will try as much as possible to relate it with where applicable to real life applications and easy method by which you can easily solve these questions whenever you encounter such. So basically, mathematics is all about formulas and approach. So it actually depends on the approach with which you use in solving a question. So once you are guided by that approach, you shouldn't have any problem or problems as it were with any mathematical questions. So now to start with, looking at the first example, said which fraction is greater, 2 over 5 or 5 over 13? 2 over 5 or 5 over 13? But to start that, so we know that fraction exists as 2 over 5. We said 2 over 5 or 5 over 13. So how would you know which of these two numbers is greater? Is it 2 over 5 or 5 over 13? You could use two approaches that comes into mind. You can convert this to a percentage. And this also to a percentage. Whatever you do to the left, you must do to the right. Either you convert this one to a percentage to check which of the two numbers is greater. So what do I mean by converting to percentage? This 2 over 5 means 2 over 5. Percentage means times 100. So 100 over 1, that's what percentage means. So 2 over 5 times 100 will give us 40. That's 40%. And 5 over 13 times 100 over 1 give us 500 over 13. And what is 500 over 13? 13 goes in 500, that will be 3. And we left it 11. 13 goes in 11 as 1 and 10. That will give us about 7. Yes, about 37 point something percent. Let's say 37.2%. So that is one approach. So you could use percentage. You can either convert to percentage, convert using percentage, convert through percentage, Then the second approach is to find the LCM, that is the lowest common multiple. So by finding the lowest common multiple, so what you are doing in essence is to gauge both the left side and the right side by using LCM, using the lowest common multiple. So let's see how that is solved. Okay, so using LCM, what do we need to do? It's just to draw a line. What is the LCM of 5 and 13? How would you know the LCM of 5 and 13? 5 and 13. Just multiply 5 by 13, that will be 65. Multiply 5 by 13, that will give us 65. 5 goes in 65, that's 13. 13 times 2, 13 times the numerator, that will give us 26. 13 goes in 65, that's 5. 5 times 5, 25. So we can see that we have a common base in this 65 as compared to this 5 and 13. So since I've unified both the left and the right hand side to 65, I can see that 26 is higher than 25. So meaning 2 over 5 is greater than 5 over 13. So that's how to solve this. 2 over 5 or 5 over 13. all you need to do is either to convert it to percentage or use the LCM approach. Using the LCM approach, just multiply 5 by 13, giving you 65. 5 goes in 65, that will give you 13. 13 times 2 will give you 26. Then 13 goes in 65 will give you 5. 5 times 5 is 25. Which of these two numbers is greater? You can say that 26 is greater than 25, meaning 2 over 5 is greater. So that solves example 1. Now we go to example 2. For example 2, the question goes thus. The question goes thus. So we have one whole number 5 over 8 plus one whole number 3 over 5, then divided by 5 whole number 3 over 8. In numerical processes, we have what we call, what I grew up to know as BODMAS, now PEMDAS. But let's go over it. BODMAS, BODMAS, BODMAS. In programming languages, we use PEMDAS. But let me just break this BODMAS in a way that it will be easily understandable. B here stands for bracket, B stands for bracket, O means off, D means division, M is multiplication, A is for addition, and S is for subtraction. So now the question is, how do we apply this? When do we use this? So you use this BODMAS shows the order with which you solve a mathematical expression. We talk about expression when we have questions like this without equals. When there's an equal to, you have an equation, but this is just an expression, meaning there's no equal sign. So solving mathematical expressions like this, we are guided by this. This is the formula. So see this formula as a constitution, something that is legally binding, something you are guided by, something you need to know. These are rules that you need to follow. Otherwise, you would be assumed to have gone contrary to the law. So that is what this is all about. That's BODMAS. So B stands for bracket, O stands for off, D stands for division, M stands for multiplication, A addition, and S subtraction. Like I said, in programming we have PEMDAS. It's just the same thing, just change of connotation as it were. Where the P, PEMDAS, let me write it out. So instead of the P, we have P, then exponential, multiplication. Oh my God, is it PEMDAS? Yes, division, addition, and S for subtraction. So, well, let's use this BODMAS. I mean, this is simple enough for our understanding. Okay, so let's just quickly go over this. So now to solve this question, so what this means is that we are to be guided by the order of this expression: bracket, of, division, multiplication, addition, subtraction. So the very first thing you need to know, B stands for bracket. Is there any brackets within the expression given? Yes, there is a bracket. So we have, let me raise this up. There's a bracket. So I want to raise the question here again. So we can see that there's a bracket here. There's a bracket. So we have 1 5 over 8 plus 1 3 over 5. You are going to solve the bracket first. So that will give us 1 5 over 8 plus 1 whole number 3 over 5. What do? We find the LCM. LCM of 8 and 5 is 40. Put 40 here. Now, this one whole number and this one whole number, they are standalone. 1 plus 1 give us 2. Divide the 2 here. Now, how many 8 can you find in 40? You can find 5. 5 times 5 is 25. How many 5 can you find in 40? 8. 8 times 3 is 24. So that will give me two whole number 49 over 40. Two whole number 49 over 40. So two whole number 49 over 40, you can see that 49 is bigger than 40. So it's just like a 5-year-old being advised to carry a 10-year-old child. You know, a 10-year-old, if a 10-year-old is standing on a 5-year-old child, you will see that the 5-year-old will feel that body. He won't be able to carry such. You won't be able to carry such because of the weight or the presumed weight of the 10-year-old child. You get. I'm just trying to create an analogy here for easy understanding. So in that wise, we have to reduce the weight in such a way that the person below can carry sufficiently. So how do we do that? So 49 is bigger than 40. How many 40 can we find in 49? We can find it once. It can go once. So because it can go once, we add 1 to 2, and that will give us 3 whole number. So if I remove 40 from 49, I'll be left with 9 over 40. 9 over 40. So that solves that. We are not done with the question yet. So now we have 3 whole number. We have 3 whole number 9 over 40 divided by 5 whole number 3 over 8, and that will give me 40 times 3 is 120. 129 over 40, 129 over 40, then divided by 8 times 5 is 40. 40 plus 3 is 43 over 8. 43 over 8. And that would be 129 over 40 times. So when you are dividing, you transpose. The 8 down will come up. 8 will be here, and the 43 will be here. So 43 goes in 129 3 times. 8 goes in 40 5 times. So the answer to this question is 3 over 5. Answer. So answer is 3 over 5. So that solves example 2. That solves example 2. Let's go to example 3. Okay, example 3. Example 3. So we have determine which is greater, 7 over 13 or 8 over 15. Just like we solved the first question, we are going to be using the LCM. So we said 7 over 13 or 8 over 15. So what do I do? I'll just find the LCM. 15 times 13 is 165. 15, 13. That's 45 and 195 rather. So we have 195. 195. Okay, so 13 goes in 195 is 15. 15 times 7 is 105. So 105. So this number is same as 105 over 195. 8 in 15 in 195 is 13. 13 times 8 is 104. So which is greater of these two? You can see that I have unified the base 13 and 15 to 195. Now the numerator here 7 is represented by this 105. 8 is represented by this 104. So which is greater? You can see that this is greater. So 7 over 13. 7 over 13 is greater than 8 over 15. Okay, that solves that. Okay, that solves that. So let's continue. Example 4. Example 4. We have 6 whole number 1 over 5 minus 2 whole number 3 over 4 plus 1 whole number 1 over 6. What can we do here? What can we do here? We can use our BODMAS approach, bracket of division. So which one comes first? So we have division, multiplication. There's no bracket, no half, no division, no multiplication. but we have addition first, addition first. So now to solve this is how to solve it. This 6 whole number 1 over 5, each number has its own sign. Each number has a sign. Each number has a sign to it. So 6 whole number 1 over 5, there's a sign in front of it. It's not written, it is plus. Once the sign is not written, it is plus. It's plus. So we have plus, it means plus 6 whole number 1 over 5 minus 2 whole number 3 over 4, then plus 1 whole number 1 over 6. So because I am adding, I can add this and this together because of the addition. This carries plus, this carrying plus. So what do I do? So I'm adding 6 whole number 1 over 5 to 1 whole number 1 over 6. Then I will now subtract 2 whole number 3 over 4. So now let's treat these two first. So I have 5 and 6 here. The LCM is 30. 6 plus 1 is 7. Standalone 7. 5 goes in 30, that's 6. 6 goes in 30, that's 5. And that will give me 7 whole number 11 over 30. Then minus 2 whole number 3 over 4. What's the LCM? So what's the LCM of this? The LCM of this, let's just assume it's 120. It's not just assumption, it's 120. But it can be lower, it can be 60. Okay, we can use 60. Rather than using 120, you can use 60. But if you don't know how to get 60, just use 30 times 4. Otherwise, it saves you a lot. So let's just use 60 because 30 can go in 60. So basically, the idea behind this is just to find the lowest common number, lowest common multiple of the two numbers. 30 goes in 62. 2 times 11 is 22. 4 goes in 60, 15. 15 times 3 is 45. 7 minus 2. 7 minus 2 is 5. 7 minus 2 is 5. 7 minus 2 is 5. So we have 22 minus 45, which is not possible. Let me clean this for easy understanding. Okay, so 5 whole number 22 minus 45. 22 minus 45 is not possible. 22 minus 45 is not possible. So what do I do? Simple. I'm writing the 45 again. So I'll borrow 1 from this 5. That will give me 4. I'll add that one I borrowed from this 5 is 60. It's assumed to be 60. I'll add 60 to this 22. That will give me 88 minus 45 divided by 60. And that will give me 4 whole number 43 over 60. So that's the answer. So that's the answer. Let's continue. So example 5. Example 5. So we have 1 over 3 minus 1 over 6. We have 1. Let me write this. Still be needing it. So that's subtraction. So the question again is 1 over 3 minus 1 over 6, then divided by 1 over 3 plus 1 over 6. So we have to solve the numerator first before solving the denominator. So how do we solve this? The LCM of the numerator is 6. That is the lowest common multiple is 6. 3 can go in 6, 6 can go in 6. 3 goes in 6, that's 2. 2 times 1 is 2. Minus 6 goes in 6, 1. 1 times 1 is 1. So the answer to the numerator is 1 over 6. What about the denominator, the one down? Again, look at this 2. The LCM is 6. 3 goes in 6 is 2. Times 1 is 2.
plus 6 goes in 6, 1. 1 times 1 is 1. So that will give me 3 over 6. What does this expression mean? It means the answer to the first one here, the answer to this one is 1 over 6. Then I say divided by the answer to the one under this one is 3 over 6. So this can be written as 1 over 6 divided by 3 over 6. That's 1 over 6 1 over 6 times 6 over 3, and that will give me 1 over 3. So that's the answer. That's the answer to this question. So let's continue. That's example 5. Question number 6 says if you express 0.575 as a fraction in its lowest term. 0.575 as a fraction in its lowest term. How do we solve this? 0.575 as a fraction in its lowest term. So we have 0.575. Now the easy way to do this is look at the question again. The question is 0.575. After the decimal point, locate the decimal point. That's the very first thing. Locate the decimal point. This is the decimal point. After the decimal point, how many digits do we have after the decimal point? We have 575. That's 3. 1, 1, 2, and 3. We have 3 digits after the decimal point. So which multiples of 10 has 3 zeros? Which multiple of 10 has 3 zeros? That's 1000. So this is 570. We write this as 575 divided by the multiple of 10 that has 3 zeros because of these 3 digits. Divided by 1000. 5 goes here, 1, 1, 5. 5 goes here, 200. 5 goes here, 23. 5 goes in 240. So this is the answer, 23 over 40, 23 over 40. That's the answer. 23 over 40 is the answer. So far so good. I want to believe and assume that you're finding this easy. Peradventure, you still have questions or you need more further clarification on any of the examples I've solved. Kindly drop me a comment in the chat box below and let me know what your questions are, and I will try as much as possible to revisit it and possibly bring it to bear in my next class. Then furthermore, if you found value so far in this class, I would appeal to you to please like, share amongst your friends that might need this basic foundation, because this is still basic foundation of maths. The aim of this channel is to demystify maths and make it more appealing, and solve as many questions as it were, and show you faster ways by which you can achieve results, especially mathematical results. Furthermore, we'll also be looking at mental math. I also teach mental math, that's teaching you faster ways by which you can do things rather than doing it the conventional way. In that way, you become smarter and you become a better version of yourself. So let's continue. So don't forget to like, share, and subscribe to my channel so that more people would see these videos. Thank you so much. So let's continue. Example 7. It said a boy has $800. He spends $160. What fraction of his original money does he have left? So the boy said there's a boy. According to this question, the boy has $800. Now he spends. Spending means he gives the money out. Out of $800 he has given out $160. He gives out $160 out of the $800 he has. So meaning left, the boy spends $160. So left, still left. I'll say boy has So boy has how many left? 800. Out of 800, he spent 160. So he will have 640 left. 640 left. Now the question is said, what fraction of his original money? Don't forget he has 640 left, but originally he had 800. What fraction of his original money does he have left? So he spent 160, he has 640 left. So original sum is equals to $800. Now the question is, what fraction does he have left? What fraction does he have left? So the fraction he has left will be the amount left, which amount left divided by the original sum of money he had. Original sum. So amount left is 640 divided by 800. 0 cancels 0. 8 goes here, 8 goes here, 10. 2 here, 4. 2 goes here, 5. So that will be 4 over 5. So that's the answer to that question, 4 over 5. So you might choose to go over this again. Peradventure, you still need further clarification on this. And if there's anything you still do not understand or you need clarification, I would urge you to please comment in the chat box below. Drop your comments to let me know what the issues are. We are here for each other. Thank you so very much. So the next question, number 8, said there are 572 students in a mixed school. 572 students in a mixed school. 5 over 11 of them are boys. How many girls are there? Definitely we know that in a school, there can't be we are not talking about any animals there. We are talking about humans. So humans, talking about humans, there are only two possibilities. Humans. There are only two possibilities. Either you're a male or you're a female. It's either you're a male or you're a female. Now, we have 572 humans or students in a mixed school. So male, we have 5 over 11 of them. 5 over 11 of 572. This is 572. Of this sum, a certain portion of this sum is for male, while the remainder will be for female. So we have 5 over 11 of means times in mathematics. Of means times 5 over 11 times 572. And what would that be? 11 goes in 572. 11 goes here, 5 rather. 5, 55, that's 22. That's 2. And that will give me 260. 260. So if I have 260 males in a class of 572, or in a school that has 572 students, and I have 260 males, so that means that females will now be 572 minus 260. And that will be 3, 1, 2. So that means I have 312 girls or females in that school. How many girls are there? That's the question. How many girls are there? So we have 312. 312. Don't forget again, let me just quickly go over it. We have even 572 pupils in that school. There are only two possibilities. Either they are males or they are females. So if they are males, 5 over 11 of means time 5 over 11 of the total number of students in that school. We have 572 students in that school. 5 over 11 of the total number of students in that school. And that's giving 260. So the female will be 312. Female will be 312. So question 9. Over to question 9 now. So for question 9, it said a notebook has 128 pages and 88 of them have been used. So we have a notebook. A notebook. We said notebook has 128 pages. Then 88 used. 88 used. So that means there are two possibilities: used portion of the notebook and the unused. So we have the unused. Unused will be from the from this 128 pages, which is total, subtract 88, and that will be 40. That will be 40 unused. 88 used, that means 40 is unused. Now the question is, what fraction of the notebook remains? Fraction means something over something. So that will be 40, which is unused. That's 40 divided by 128. And that will give me 10 over 32. And that will give me 5 over 16. So that is the fraction that is unused. Fraction that is unused. Thank you so much. So lastly, we go to question 10. This is just part 1 of numerals and this topic as it were. So we'll be going to part 2 tomorrow. But be that as it may, let's solve the last question. The term which is greater, 7 over 9, 7 over 9, 3 over 4, and 10 over 13. Just like I said in the very first example, what we need to do is just to find the LCM. What is common amongst 9, 4, 13? How do I get the LCM of 9, 4, 13? It's very easy. So you can just come here, draw your LCM. You have 9, 4, and 13. So you can get the lowest common multiple like this if you don't want to multiply everything. So we said 3 goes here, 3 cannot go in 4, 4, and 13. 3 goes here, 1, 3 cannot go in 4, right? 4, and 13. 2 goes here, 1, 2, 13. 2 cannot go in 13, so you write 13. 2 goes here, 1, 2 goes into 1, then 13. Then what can go in 13 is only 13. Where's the prime number? So now 3 times 3 is 9. 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. So you have 36 times 13. So that will give me 108 and 36. So that will give me 468. So that will be 468. So if 9 goes in 468, what will it give me? 52 times 7. 52 times 7. 52 times 7. Permit me to clean this place, please. So I'm trying to create an atmosphere by which we all will understand this. It's not difficult. So we say 52 times 7. 52 times 7. And that will give me 12. That's 362. So this will be 362. So a fraction of this 468, 362. 4 goes in 468 is 117. So 117 times 3 will give me 51, 351. So this represents 351. That's fraction of this. So 13 goes in 468. How many times can 13 go in 468? 13 times 4 is 52. 13 times 3 is 39. 13 goes in 78 is 6. That's 36. 36 times 10 is 360. So the question is said, which is the greatest? Which is the greatest? You can see that this number is the greatest. 362 is greater than 360, followed by 351. So just like I said, the solving questions like this is just to find the LCM. If you don't want to find the LCM, you can use the percentage. I could have taken these numbers to percentage. 7 over 9 times 100 over 1, or 3 over 4 times 100 over 1, or 10 over 10, 13 times 100 over 1. But the easiest way is using the LCM approach. So with this now, it's just like we have a full cake. This is like a cake. This 468 is like a cake. So the fraction that belongs to this 7 over 9 is 362. The fraction that belongs to 3 over 4 out of this full cake is 351. And the fraction that belongs to 10 over 13 out of this cake is 360. So the greatest of these numbers is 7 over 9 is the answer. So this brings us to the end of today's class on this topic. We'll still be solving more in our subsequent classes. And to this end, I would urge you, if you found value one way or the other from this class, please, this is a new channel dedicated to mental maths and to teach maths as much as possible, to explain the rudiment of mathematics
in a way by which you understand it, and to, the idea is to demystify it and to make it simpler. Math is simple. Like I said, I always say it all depends on approach. So the approach here is to teach you faster ways of doing solving mathematical questions, and also to teach you mental mathematics, that's to help your reasoning and make you become smarter. So if you found value from today's video, please like, share and subscribe. Please hit the bell notification below. Drop your chats and drop your comments in the chat box below, where your questions are. See you in the next class. Thank you so very much.